She needs the other the same happen where she needs to restrict it and then
share my screen. All right, so let me introduce an application called PyMol. So you want to go to the applications folder, go to the SciViz folder, and open up PyMol. When you open it up for the first time, it might ask you to locate a license file, in which case you'd have to click the little message that comes up to locate that license file. It should be on the hard drive in the applications folder in that Perkins SciViz folder, if I can ever find it. There it is. There's this file called pymol.edu or pymol.edu license.lic. You want to navigate to that and select that as the license file. And then that warning should go away. That simply means that we've registered for an educational license for this particular software. You can actually use the software even without registering for an educational license. But if you export any images from PyMol, if you haven't registered with a properly registered version, it's going to put a little watermark across your image that says, unlicensed version, unlicensed version. So just to make sure that we don't get those watermarks on our exported images, it's important to actually have a properly registered copy. All right, so this is the PyMol interface. And in that set of sample PDB and mol files, there are some subfolders for things like biological molecules. There's some drugs, some miscellaneous stuff, nucleic acids like DNA and RNA, some proteins. We'll come back and look at these in a little bit. I'm going to open up a biological molecule in PyMol. Now, if you simply double click on one of these PDB or mol files in that sample molecule folder, it's going to launch Chimera, because I think Chimera is set up on these computers as the default program to open any of these molecular model formats. So in order to open them in PyMol, you have to open PyMol first, and then you can simply drag the molecule into PyMol, and it opens up. So I just dragged in something called sphingomyelin, which is actually a phospholipid that would be found very commonly in the lipid bilayer of cell membranes. And these phospholipids consist of a molecule of glycerol in the middle, which you can't really make out here. Two long fatty acid chains. Those long zigzagging green chains are long fatty acid tails. Those are the little zigzags that you see in representations of the lipid bilayer. When you see the little lollipop with the two little zigzagging tails, those are the lipid tails. So that's what you're seeing here. And then the orange atom with a couple of red atoms sticking off of it, that's the orange atom is phosphorus. And then in this case, there's something else that's attached to that phosphate group. So sometimes you'll have like a sugar molecule or something else that's attached to the phosphate. I'm not sure exactly what that particular molecule is that's attached to the phosphate. But so the long fatty acid tails would be the hydrophobic portion of this phospholipid that would face towards the interior of the lipid bilayer, away from the water, away from the cytoplasm, or away from the extracellular fluid. And then this other end with the phosphate group on it would be the polar head, which would be facing towards the water, either facing externally towards the extracellular fluid or facing internally towards the cytoplasm. So now that we've got this molecule open, there's a few things we can do with it. Let me show you some of the menus and some of the settings that we can employ to play with this molecule. There are a couple menus up here that I use pretty frequently. There's a display menu that is going, there we go. One thing that I don't like about PyMol is the only way to change the size of the molecule in your display is using this zoom setting. You know, I've played around with keyboard shortcuts. Most of your molecular visualization programs actually have keyboard controls that allow you to zoom in and out, but it seems like with PyMol, you just have to choose one of these settings, and it's not intuitive at all. I think if you click all right, nothing happened. If you change the size of the sphere, it changes your magnification. So choosing a smaller diameter for your sphere zooms in, which doesn't seem to make any sense. Seems kind of counterintuitive. Then you choose progressively larger angstrom spheres, and then you gradually start zooming out. So, you know, I'm really not that crazy about this method for zooming. You can move around. You can translate by just holding the Option key down. You can translate. Normally, with most of these programs, you can hold something like Shift or Command or something like that, and then that lets you zoom in and out, but not in PyMol.
Hey, Jim.
Yeah.
I've used PyMol in the past, and I thought you could hold down the right mouse button and go in and out.
Maybe. Oh, look at that. Hey, what do you know?
Hey.
I'm so used to working on a Mac with only one mouse button that I don't ever do that.
Okay.
So, okay, well, that's good to know.
Okay.
So you can simply right click and drag in and out to zoom in and out. That's handy.
Okay.
All right, so you can simply hold either Command or Option to just translate, and then right click to zoom in and out. Good to know. All right, so you probably don't have to worry so much about the zoom menu because it is kind of counterintuitive. There's a background menu that just lets you change between certain standard background colors. You can render these and export these things, so you might want to change your background color before you export an image. You can change the color space, although I don't normally worry about this. I just let it export images in RGB, and then if I need to change it to CMYK, I'll open it up in Photoshop and do it there. So I don't worry so much about the color space. Quality is helpful, especially if you are going to export these images and actually use the exported PyMol image. I would go up to maximum quality. And I don't know if you could tell, but it actually smoothed out the edges a little bit. They were a little pixely looking before, and that smoothed them out a little bit. Something else that's very useful to be aware of is there's a setting called orthoscopic view. You might remember this with Horos, that you had the choice between viewing the body in perspective view or orthoscopic, or sometimes called orthographic view. In PyMol, by default, when you first open it, it is in perspective. So you notice when I rotate this thing around that some of these sticks appear fatter and some of them appear skinnier because of perspective. But if I switch the display to orthoscopic, it didn't change much there. But when I rotate it in 3D space, then there's no sense of perspective anymore. So depending on what you're trying to do, I tend to work in orthoscopic view preferably, and eliminate that sense of perspective. There's some other things down here that are turned on automatically, like depth queuing. Depth queuing is a way of creating a sense of perspective also. Notice how when I rotate this molecule, one of those green fatty acid tails is kind of disappearing into the distance. It looks kind of like it's disappearing into fog. That's depth queuing. It's just using a sense of atmospheric perspective to accentuate the sense of depth. Even though I have perspective turned off, with the depth queuing turned on, you know, things in the distance seem to kind of fade away. I'll come back to the setting menu in a minute. Let me show you over here on the right. There are these 5 little buttons just to the right of the name of the particular molecule. Now, the one I opened was called sphingomyelin. So to the right of that, there's an A, an S, an H, an L, and a C. A is an action menu. And don't use this too often, except down here, there's a submenu called hydrogens. And there's an option to the left to add. And if you look closely, let me zoom in on this to a certain part of this molecule. When I go to the action menu and I say hydrogens add, it's going to add missing hydrogens. It's going to calculate the valence of each atom and put in any missing hydrogens. And sure enough, it added a couple of missing hydrogens, although I think it may have added them inappropriately, because I think some of these oxygens are double bonded and probably shouldn't have an extra hydrogen on them. So I'm not sure that's a great thing to use. I'll show you another molecule in a few minutes where there's an action here called remove waters, which can be very useful. This particular model, being a small molecule like sphingomyelin, usually you don't have water in there, but what we'll find is that some of the more complicated molecules like proteins, where the structure was determined by X-ray crystallography, oftentimes there's actually water that's included in the protein molecule. You'll actually have a handful of water molecules in there, so removing the waters can be helpful there. The next little button to the right of the name is the show menu, and this is where you turn on different kinds of representations. There's a line representation, which we can't really see now. If I turn on the line representation, it's not visible because that line representation, which is like kind of like a wireframe, it's actually hidden inside these sticks. So I'd also have to use the H menu, which is the hide menu, to hide the sticks. And now the lines that I turned on in the other menu are visible. I could also hide the lines, and now everything's hidden. But I could go back to my show menu. I could show the sticks. I can hide those. So I just go back and forth between these menus. I can show, they don't really have a true ball and stick, or at least there's nothing listed under here called ball and stick. But I do know if I choose the stick representation, and I go up to my settings menu under lines and sticks, I can actually change to more of a ball and stick representation. Now, it didn't look like it did anything, but if I go back and change the ball and stick ratio, now the balls, the atoms are 1.5 times the diameter of the sticks. So that's the only way to get a true ball and stick representation. You have to choose stick and then play around with the stick settings up here under the settings menu. We can hide that as well and go to show, and they don't call it space filling or CPK, they call it a sphere representation. So we can choose spheres. And now we get that space filling representation. I'm going to go ahead and turn off the depth queuing to get rid of that fog effect. But you can tell that these the atoms are now represented by their van der Waals radii, and all the atoms are actually overlapping and intersecting with their neighbors if they're bonded to one another. Some of the other things under here, like ribbon and cartoon and surface representations, those are going to be mostly useful for proteins, although, I mean, you can add a surface. So you can add a 3-dimensional surface to this thing, and then we can hide the spheres. You still just see the surface there. Surface doesn't really make a whole lot of sense for a small molecule like this. So I'm going to hide the surface. turn my spheres back on. So some of the others are going to be more useful for things like a protein. Well, let's see what else. So again, hide just lets you hide all of the things that you can show under the show menu. There's an L here for labels. I don't ever bother with labels. If I'm going to put labels on a molecule, I'll add those labels separately in Illustrator. I don't do it in here. The final button here is the C, which you might be able to tell from the rainbow. That's the color menu. This works well for some things, but not so much for others. You've got some submenus here, like color by element, color by chain, color by SS, which means secondary structure. That's only going to be useful for a protein. But even color by element, the very first option here seems to have a black carbon, a light gray hydrogen, blue nitrogen, red oxygen, yellowy orange, sulfur. That seems like the standard CPK color scheme. But when I select that, it doesn't change anything in my molecule. One thing I don't care for about PyMol is that it automatically opens carbons as this bright green. And then if you open another molecule after it, it might open the carbons as bright yellow. And you open another molecule, it opens the carbons as bright pink. And I don't quite get that. I don't know why it chooses all these weird colors for the carbons. Why not stick with the standard dark gray from the CPK scheme? There is a way to change that. If you go back to the settings menu and go to colors, you've actually got a list of the elements over here, and I can choose carbon, and you can see that it's coming up as this RGB formula here to give us a bright green. I'm going to change that to, like, let's say, I don't know, 0.6, 0.6, and 0.6. If all of the values are equal, you're going to get either a white, a black, or a neutral gray. And by choosing 0.6 here across the board, and I apply this, I should get a gray. I might go a little darker than that. Maybe, 0.4. A smaller number is going to give you a darker color because it's RGB space. So then now I got my dark gray, which is more typical of carbon. So in order to change the color of any of the elements, you have to come up to this color palette, change the RGB values, and click apply. Going back up to the settings menu, you have all these controls for different kinds of representations. So I showed you how you can change the ball and stick to actually, look like a true ball and stick model. Later, when I open a protein, they use the word cartoon for what I would call a ribbon model. And you can change various settings for that. What I call a ribbon model, they actually call or what I would call a backbone model, they call ribbon. So their usage of the terms is kind of backwards from the way these things have been named historically. We'll come back to that later. Surfaces, if I were to go back and add a surface, let me hide the spheres and show a surface. I can change the setting of the surface. I can make it a dotted surface. It looks like a bunch of little dots. I could make it a wireframe surface like that. I think I can also control that over here as well. I think I can, if I hide the surface, if I show, maybe not. Oh, I can, yeah, mesh. That's what I was thinking of. There's a mesh setting. Hide that. If I show both a let's do a stick model. And let me add a surface to that. Let me change that surface to just solid though. But I can also go down here to the transparency submenu under settings, transparency surface, and I could make that surface partially transparent to allow you to see the stick representation on the inside. So that creates kind of a cool effect that you might want, you know, if you were trying to illustrate an image like this. Let's see, anything else? I think that's about it. If I wanted to actually save this image, there are a couple of ways I could actually save this image. I could export it directly from PyMol. I can go up onto the file menu and I can say export image as. Now there's actually a couple of 3D model formats here, like VRML is a 3-dimensional model format. So I could actually save this as a 3D model and then bring it into another program like Cinema 4D or Maya. But if I just want to save this, or STL would work too. VRML or STL are 3D formats that would allow me to bring this into Cinema 4D or Maya. But if I just want to save a 2-dimensional graphic, the only option it gives me over here is to export a PNG file. And then, so I'm going to call it sphingomyelin. It should automatically add the PNG suffix, put that on the desktop, and click save. And let's see if it actually did that. Here it is as a PNG file. And I could open that up in the preview application on the Mac. The problem with this is that it doesn't allow me to specify the size of the PNG file. It doesn't allow me to specify the resolution, the pixel resolution of the PNG file. I'm stuck with just, I think it's a relatively low resolution PNG file and it's RGB. So using the export image and exporting a PNG, it's probably sufficient if you wanted to export an image that you were then going to bring into another program for further rendering. So for example, what you're going to do today as an exercise is you're going to export a model from PyMol. You're going to bring it into Illustrator. So if you just wanted to export something and bring it into Illustrator as a template, that would be fine. But it is possible to export these images as high resolution publication quality images. It's just a little less intuitive how to do that. Instead of using the file menu and saying export image, you actually have to click way in the upper right corner. There's a button called Draw Ray. And the ray is referring to ray tracing. It's almost like the ray tracing rendering engine inside of a 3D program where it traces beams of light, from the light source to the object and then back to your eye. So this lets you do a ray tracing model. So if I click on that, here it actually lets me specify the number of pixels and the physical dimensions. So I'm actually going to change my units here from centimeters to inches. And I could make this thing, say, 12 inches by, I don't know, 9 inches or something like that. And then I can specify, I hate the fact that it says DPI because that's a misnomer. It's a misuse of the term. It should say PPI for pixels per inch, but I mean, most people know what it means. So I could put a higher resolution in here, like 300. And now I've got a really big image that's big enough to put on like the cover of a textbook. And it's at 300 pixels per inch. So it's appropriate resolution for publication quality. And then I can click the Ray button here. And it says slow, but it's really not very slow. It's done. So that's not very slow. And then I'm going to save that image to a file. So we're going to call that call that sphingomyelin 2. Now it's still saved it as a PNG file, but it's a much, much bigger PNG file. And if I were to open that in Photoshop, we'll see that it should be pretty big and should be high resolution. So here it is in Photoshop. If I go to my image size, you can see it really is those dimensions. It's 13.97 by 9 inches by 300 pixels per inch. Notice also that it has a transparent background. I forgot to point that out, but when you click the draw array image, let's see. Yeah, there's a checkbox here to get a transparent background. So this PNG file actually has a transparent background. So if I added, another layer, put another layer behind it, and actually drew something on another layer in the background, you can see that the molecule is in fact transparent, and you can see that pink background showing through it behind. So saving something with a transparent background can be a useful thing. All right, so I'm just going to click on the name of this molecule. It's going to hide it. And I'm going to open up a new molecule. This time I'm going to open a protein. So I go back into my sample PDB file folder here, and I'm going to choose proteins. I got a lot to choose from. I'm going to choose this one specifically, the MHC class 1. Bring that in. And notice that as a protein, it automatically brings it in as a ribbon model, although it doesn't call it a ribbon model. It calls it a cartoon model, which again is kind of ass backwards from the terminology that most people utilize when they're talking about images of proteins. But, notice the little red X's scattered throughout. Those are water molecules. Remember I mentioned before that some of these proteins that have been solved by X-ray crystallography, oftentimes there are water molecules that are captured as part of the crystal, and they actually show up as part of the PDB file that's generated from the X-ray crystallography. So we don't want those to show up if we wanted to export this. If we wanted to either export it as a 3D model or as, just export an image. So this is where we can go to our actions menu and say remove waters. And they all disappear. So different kinds of representations for proteins. Let me hide the cartoon. Oops, clicking on the wrong thing. Hide cartoon. So we could show it as sticks. So there's our ball and stick type representation. Now remember, I had to change the settings for ball and stick up here. If I turn off that ball and stick setting, then I just get sticks. I don't get the balls anymore. But let me go ahead and put that back on. The carbons are all showing up this time as turquoise instead of dark gray. So I don't know if I have to go back to my colors again and go back to carbon. I mean, it's probably still set. Yeah. Well, let me try applying that. Okay, now it's not working. It's not letting me change the colors. Let me try over here, color by element. Try this one. No. So it worked the first time, but now that I brought another molecule in, it refuses to colorize the carbons the way I want them. So that's a kind of a weird little glitch with PyMol, if you ask me. Now, if you look really closely at this, you might notice something weird about this molecule. There's a lot of carbons, a lot of oxygens, and a lot of nitrogens, but not a single hydrogen anywhere to be found. All of the hydrogens are implied, but they're not shown explicitly. So this is where we can use another one of our actions. Go down here to hydrogens and add hydrogens. And that just added a whole lot of missing hydrogens. I can hide the sticks, and I can show it as a sphere model. Now you can see all those hydrogens all over this thing. So now we're seeing every single atom represented as a space filling or CPK model. I could hide those. I could show the surface. It might take a second to calculate. Let's see. So there's our surface representation. I can hide the surface. And now I showed you, this is what they call a ribbon model, which makes no sense at all. This is what I would call a backbone model, not a ribbon. Let's hide the ribbon. So what they call cartoon is what I'd call a ribbon model that distinguishes the alpha helices, which are the spirals, and the beta sheets. You can see the arrows, and you can see how we've got an arrow that comes down and does a turn and comes back again, zigzagging back and forth to form a beta sheet. Let's see. In our color menu, I tried showing you color by element, and even when I was showing you the individual atoms, it didn't seem to work very well. I can color by chain, and it doesn't really matter which of these I choose. If I color by chain, you'll see that there are two distinct chains here. This is MHC, I think MHC class 1. So this is the major histocompatibility complex, which is molecule that's really important, where an antigen presenting cell, will consume some foreign substance or whatever, and then present a piece of that on its surface to a T cell to recognize that as something to mount an immune reaction to. So this MHC, this major histocompatibility complex molecule, is a surface protein that would present an antigen to a T cell. It has two different chains, though, and you can see that by coloring by chain, we see the distinction between this dark gray chain and that sort of turquoise chain. I don't know if these other chain options would give me different colors. Seems to me I remember yet, no matter which of these I choose, it always gives me these same colors. I think that gray is kind of ugly. Now, something else I could choose here under color, instead of coloring by chain, I can color by SS, which is short for secondary structure. So if I choose one of these, I get 3 different color choices. If I choose color by SS, it's coloring by secondary structure. So the alpha helices, which are one component of secondary structure, they're colored turquoise. The beta strands, which make up these beta sheets, colored in that magenta color. And then the kind of, salmon-y color, pink color, connecting them. Let me try the other color scheme. That might be more obvious. Yeah. In this one, the green things are just sort of random loops and turns connecting the other secondary structure elements together. So you've got all these different ways of representing proteins. So you can have surfaces, ribbons, and things like that. You know, I can add a surface on top of the ribbon, and then under my settings up here, I can change the transparency of the surface. In fact, it remembered from last time to make the surface 60% transparent. If I make it 80% transparent, it's even more transparent, more, you know, it's lighter, so you can see the ribbon inside better. So you can combine these different representations. And then, you know, same thing as before, you could go up here to export image. You could choose VRML or STL to export an actual 3D model. You could export it as a PNG, or we could go up here to our draw and ray trace option, export it as more of a high resolution image, and you can turn the background on, you know, the transparent background on if you want. Right, so I chose ray tracing again as my option. This one's taking a little bit longer. Then if I open that, you can see it here in preview. All right. So that's a pretty quick intro to PyMol, but that's really all I wanted to show you in PyMol. Let me walk you through today's exercise. Actually, why don't we take a short break since we're at a good stopping point, and then I'll walk you through the exercise for today. Share. All right, so during our short break just now, I ended up quitting PyMol and then reopening it. The reason being that if I want to change the color of carbons, seems to me that once you open a second molecule, even if you go up to the color settings and try to, you know, and change the color of carbon and try to apply it, it just doesn't ever seem to work anymore after you've opened that second molecule. And it's kind of a frustrating bug in PyMol. Not sure why it does that. So I've reopened PyMol, and your exercise involves doing a space filling model of some drug. And I believe all of these are on the list that I gave you. You can pick something different besides what's on that list. The only thing I ask, the only requirement is that it has to have at least one ring in it, because rings are challenging to illustrate in Illustrator, and I'll show you some of the reasons why that can be a little challenging. So I'm going to take something like, I don't know, let me try this ibuprofen. Yeah, that'll work pretty well. I'm going to hide the sticks, show it as spheres, because I'm going to create a space filling model. And probably change the background to white. Doesn't really matter that much, but I think it might just make things a little easier for you. I'm going to make sure that my quality is set to maximum, although we're going to redraw an Illustrator, so it doesn't really matter, but it might just give you a little bit better image to draw from if you set it to maximum quality. Let me go ahead and change the color of those carbons, and hopefully it'll actually work this time because of Process of closing, there we go. So one of the things that's a little bit tricky about this exercise, I mean, it's not that big a deal, but before you export a ping of this model, you want to try to orient it in a way that allows you to see the entire thing. And that can be really challenging. It's one of the downsides to using a space filling model is because of the big spheres. You know, if you orient it in such a way to see these two methyl groups that are pointing towards us, these two CH3 groups, then I can't see that there's an OH group, a hydroxyl group on the other side. And if I flip it around to see the hydroxyl group, now I can't see either of those methyl groups, and I can't really see that double bonded oxygen very clearly either. So see if there's a way that you can orient this thing so that you can see a lot of it, or most of the important functional groups of the molecule. But I also want to be able to see that ring, because that ring is going to be an interesting challenge to illustrate. But let me stick with what I have here. This looks pretty good. So I don't need to use the ray tracing thing for this. I can simply just go up to export image as ping. And save as, and what is this? Ibuprofen. On my desktop. Click save. And I'm done with PyMol for now. And now I'm simply going to open Illustrator. All right, so here in Illustrator, some of the same precautions that I gave you on the ball and stick model that we did. Don't just grab the ibuprofen image and drag and drop it into the Illustrator and try to open it that way. That's probably going to give you an RGB file, which it did. It's not going to allow me to control the size of the image. Instead, and don't just go to the file menu in Illustrator and say open and select that. It's going to do the same thing. So what you want to make sure to do is create a new file in Illustrator. Make sure you set it up the way you want. And remember, we ran into an issue with like the raster screen effects before. Some people, put like cast shadows or inner glow, and there was a lot of pixelization. If you choose the print preset up at the top, and then choose letter size, by choosing print preset, we get the correct color mode. So we get a CMYK color file, and we get the high resolution raster effects, just in case anybody's planning to put cast shadows or inner glows or any of that stuff into the image. Choose the orientation that makes sense for whatever molecule you exported. I happen to export my ibuprofen molecule kind of horizontally. So I'm going to choose a horizontal landscape format. Just double check, make sure it's CMYK with the high resolution raster effects, and click create. Now I'm going to use the place command to actually get that ping file, place it in here. Now it's really big, it's bigger than it needs to be. So I'll use the scale tool to just scale it down. And then position it where I want. So now it's filling, most of that 8.5 by 11 space. Actually, the ping file goes beyond the edges, but that's just the white background. The molecule itself fits within my 8.5 by 11 space. So then I would go to my layers palette, lock this layer to make sure I don't inadvertently move it around. And I'll try to remember to repeat this again later, but don't forget, last step before you upload this thing to my courses is make sure you delete that placed JPEG, or in PNG file in this case, make sure you delete that placed image, because otherwise when I try to go open your Illustrator file, it's gonna yell at me and say, hey, where's that missing PNG file? So I placed that on its own layer and locked it. Now I'm going to create a new layer. And this is where I'm actually going to start creating my, my artwork. There are two general approaches to this. And the trickiest part of this particular assignment is the fact that in order to show these spheres looking like they're actually intersecting with one another, it's going to be necessary to actually trim parts of some of the circles that you draw for these spheres. So I'm going to open up my ellipse tool and show you what I'm talking about. I'm going to start out by drawing the carbon atom. And nowhere in here can I actually see an entire carbon atom. Every one of these carbon atoms is partially blocked by other atoms, or it's intersecting where it bonds with its neighbors. So you have to try to visualize what would be the full size, the full diameter of a carbon atom. And I'm going to try to eyeball it here with this one. Might help if I had no fill in there. It's still not quite big enough because it's not quite reaching the left-hand edge. And so I might need to just scale that up a teeny bit. Yeah, that looks about right. So that circle is now the size of that full carbon atom if it wasn't, you know, intersecting its neighbors. So I'm going to pull that off to the side over here. And so I was starting to say that there are two basic approaches to how to do this. One approach would be to actually put the gradients in right away. So I'm going to take this one circle that I just drew, and I'm going to create a radial gradient for my carbon. So I'll just click the default gradient in the gradient palette, and that fills in my circle. But I don't want a linear gradient. I want a radial gradient. Please don't use the freeform gradient. They do not create convincing spheres. So I've got my radial gradient. I want to have 4 sliders for highlight, midtone, core shadow, and reflected light. So I'm going to click a slider here. That'll be my midtone. Drag this black one over. That'll be my core shadow. Add a 4th one over at the far right. That'll be my reflected light. So I always start with my midtone value. Select that, look up at my color palette. It's 30.97. So I want this carbon to be a dark gray. 30% black is kind of on the light side. So I'm going to pick a darker gray. I don't know, let's go say 60%. I could make it a slightly bluish gray if I really wanted to. I could just throw a teeny bit of cyan in there. That's not really necessary, but I find that adding a little hint of color to the gray makes it look a little better. My highlight, I don't know if I want a perfectly white specular highlight. I might throw, you know, a tiny bit of cyan and maybe a little bit of black in there to have a little bit softer highlight. My core shadow, I never want this to be completely 100% black. I'm going to throw a little bit of cyan in here as well. And then maybe I'll go about, say, 80% black for the core shadow. Then my reflected light should be a lighter version of that. So maybe 5 on the cyan, and instead of 80, do, I don't know, 65 or that's almost my mid-tone color. So let me go a little darker, maybe 70. And now I'm going to take my gradient tool, and remember how I like to position the gradient in the circle. I'm going to draw some guides on here just as a reminder to show you how to do this, or at least how I like to do it. I'm just going to pull some guides over to help you visualize how that circle is divided up into 4 equal quadrants. Even though my ping file that I exported has our light source kind of in the upper right, I'm going to ignore that. I'm going to put the light source in the upper left, just because that's standard for scientific illustration. So I'm going to take my gradient tool, hold the cursor somewhere over that upper left quadrant of the circle, click, and then drag right through the center dot of the circle until I get down to the bottom right edge of the circle, and then let go. Don't drag way out here, because then you're just going to have to mess with your gradient to fix it. Just let go right when you get to that bottom right-hand edge of the circle. So now we got a nice highlight, midtone, foreshadow, reflected light. I could play around with these. I could move this little diamond. Whoops, that's not what I wanted. Move this little diamond over to the left a little bit to make the highlight a little narrower. I can take this other diamond that lies between the midtone and foreshadow, drag it to the right. That creates a little bit more of a hard edge on my foreshadow. I mean, I don't want a perfectly hard edge, but a little bit harder than what it was originally. That works pretty well. So I've got a pretty convincing radial gradient now to make this thing look like a sphere. So in this first approach, you would draw all your gradients first, and then make copies of these things and drag them over here. And then just make copies of those. So there's one carbon sphere there. There's a carbon sphere up here. And there's a total of 6 of them, because this is basically a benzene ring here. So there are 6 overlapping carbons. You know, I could draw all 6 of them, I suppose, although it's hard to know exactly where they belong. And clearly this isn't looking exactly right, because I haven't done anything to make them look like they intersect yet. So I'm going to go ahead and get rid of a couple of those and just focus on these 2 for now. I need to make these 2 look like they're intersecting. So I don't know if you remember this little trick from last time. If I want to make these spheres visible only as outlines, if I want to view the spheres only in outline mode while still being able to see the image in the background, I hold the Command key and click the eyeball icon next to layer 2. That layer now is visible only in outline mode, whereas the rest of the image is still visible. And I realize now that I've done that, I need to reposition these a little bit, because I didn't have them exactly where they needed to go. And I think I need to make that one, yeah, that's pretty good. All right, so now I need to make these 2 spheres look like they're intersecting. You can see in the ping image in the background that there's this gentle curvature to the edge where the 2 spheres are intersecting. Let me show you a really good way to do that. There are lots of ways to do it. You can just try to kind of draw it by eye, but you're going to get lousy results. There's a much easier way to do this where it's going to really look exactly like that edge there. Let me just do one more thing here. Let me just nudge this down a teeny bit. There we go. All right. So I'm going to take my pen tool, and if I position my pen tool over the selected segment of that line, I don't know if you can see it or not. Maybe if I put it over the white part, over the hydrogen atom. When I position the pen tool over a selected segment of path, the pen tool gets a little plus sign in its bottom right corner. So it becomes the add anchor point tool. That's going to let me add an anchor point, and I'm going to add an anchor point to the left circle right at that point where they intersect. Then I'm going to do the same thing down here. I'm going to hover the cursor over, or hover the pen tool over the selected circle, add another anchor point right at that point where they intersect. Now I'm going to take my pen tool and I'm going to position it over these existing anchor points. And when I position it over an existing anchor point, the pen now gets a minus sign, becomes the delete anchor point tool. So I can delete this anchor point, delete this other anchor point down here. Now look at that. The edge of that circle is now almost exactly running right along where that edge should be. Now, I need to do one little thing to modify this a little bit. It's pretty close to running right along that edge, but not exactly. So what I want to do is I want to take my white arrow, and I'm actually going to grab that segment of path, and I'm just going to pull it over a little bit so it lands right on that line on my PyMol image. But I can pretty much guarantee you that it's not going to work right, and I'll show you a fix, but I'm going to show you what's going to happen most likely. As I try to drag this line over, notice what's happening to my handlebars on those anchor points. The handlebars are wobbling around in a weird way. And even though I may be able to position this path exactly where I want it, it's moved the handlebars and affected other parts of that circle. So it's no longer going to look like it's no longer going to look like a perfect circle. Look how flattened out this edge became on this circle. It's because this handlebar, rotated around in a weird way when I was pulling on that path. This is all a result of a thing that Adobe changed a number of years ago, where they took a perfectly good tool and almost used an expletive there, took a perfectly good tool and messed it up. The grads have heard me rant about my hatred of Adobe things. So I just undid that, and I'm going to show you what you need to do to get this thing to behave better. Let me go back to this. Let me click, command click on the eyeball to go back to preview mode here. Especially on this particular assignment, I think it is really critical to go up to your Illustrator preferences under Selection and Anchor Display, and you want to check off this kind of vague sounding thing here called Constrain Path Dragging on Segment Reshape. This is the way Illustrator always worked up until, I don't know, 5, 6, 7 years ago. That when you moved a segment of path, the handlebars didn't rotate around. And then some genius at Adobe decided, hey, let's change Illustrator so that when you drag a segment of path, the handlebars rotate around in all kind of wonky ways. And the Adobe forums lit up with hate mail because none of us appreciated that change, because it completely screwed up how things behaved in Illustrator. So it took them about 6 months, but they finally then added this option in preferences. Now the default is for this to be turned off. So every time I sit down to work at Illustrator, I mean, I have the default, or I have these things set up correctly at home. But whenever I sit down at a computer here at RIT, I have to make sure to turn this on before I start working. So I'm turning on Constrained Path Dragging on Segment Reshape. Now watch what happens when I drag out this piece of path. It just drags it out and, you know, makes it a little curvier, but it's not making my handlebars rotate around in weird ways. You know, I could drag this way out here if I wanted to. I could drag it back this way. Okay, that was a bad example, but I could drag it way out here and it would look fine. So this allows me to simply drag this path and position it exactly where I want it, right along that edge on my PyMol image. But keep in mind that this circle has now been sliced and diced. It's no longer a perfect circle anymore. If I want to create another carbon, I probably want to go back to this one because this one is a perfect circle. I'm going to put it over here. It's really hard to know where this carbon sits because we really only see a little piece of it. And I'm going to have to slice and dice this one a little bit too. Now it looks as if the second carbon that I drew, this one here, you can see what I'm circling, looks like that one is that in front or behind? Okay, it's in front. Okay, that's good. So I'm now going to select this one, use my pen tool, add an anchor point. Conveniently, there's already, looks like an anchor point down here right where I want it. So I don't even have to add an anchor point down there. I just have to delete this one and then just use my white arrow and reposition that line. It's not perfect, but it's pretty good. There's another carbon over here. And now that one kind of looks like it's in front of the previous one. So I'm going to have to object, arrange, bring forward or bring to front. Doesn't matter. I'll probably just bring it to front. Now when I go in here, oops, same kind of thing, just add an anchor point here, add one here, delete this one, and now it's pretty close. Just drag it over just a little bit to get it to line up with that line. Now I was saying before that there are, I think that probably has to come forward maybe. It doesn't really matter which of these is in front and which one's behind because I'm pretty sure there's a hydrogen that covers that. Yeah, there's a hydrogen in here that's going to cover that up. So it doesn't really matter if we get that exactly right. I was starting to say before that there are two different approaches to this. The first approach is what I was just showing you, where we start with our gradients and then, you know, start slicing and dicing the gradients by, you know, adding anchor points and deleting anchor points. Yeah, the thing I'm not crazy about with that approach is, this is another thing that Adobe changed. It used to be that if you had a gradient and you had that gradient positioned in the object exactly where you wanted it, it used to be that even if you deleted a bunch of anchor points, the gradient stayed where you put it. The highlight, the midtone, the core shadow, the reflected light, everything stayed in the same position, even if you started removing lots of anchor points. I don't know if you can tell here though, as I remove anchor points, it's repositioning the gradient, repositioning the highlight, the midtone, core shadow. And that just annoys me to no end. Because what it means is if I delete a whole bunch of points and dramatically change the shape of the object, since it's repositioned those gradients, I'm going to have to go back in here with my gradient annotator and reposition the gradients, trying to imagine, okay, where would the sphere be? What would it really look like? So that's a little bit of a nuisance. The other approach you could take would be to just use something that's filled with like a flat color. Like I could just put in, say, 50% gray here. And I could, start drawing my atoms just with something that's filled with solid 50% gray. And then start doing my slicing and dicing, adding anchor points, deleting anchor points, moving paths around a little bit. I could get all of this stuff exactly where I wanted it. Why are you doing that? Get all these things exactly where I want them. Do all my trimming, and basically finish the whole thing. And then at the end, I could say, okay, I could select one of these, say select same fill and stroke. I'm just going to select everything that has that same fill color and stroke color, grab my eyedropper tool, and then just pick up the gradient. Now I'm still going to have to go back in here and reposition them all. Still have to look at this and say, all right, where's my upper left quadrant? Click, drag through the center, and release. It's a little harder with this one because I've only got a little chunk of a sphere left. It's harder to figure out where the upper left quadrant should be, but I'm going to kind of imagine up there. And I'm going to drag down and imagine, all right, where would my bottom right edge be if I hadn't trimmed it off? Maybe about there. This one's still a circle, so this one's easier. Upper left quadrant, through the center, down to the bottom right. So the only difference being, you can either have your gradient present at the beginning before you start slicing and dicing your atoms, or you can simply fill them with a flat color, move them around, slice them and dice them, and then add all the gradients at the end. So remember, I'm also going to create gradients for, in this case, I've only got 3 atoms, or 3 elements. I've got carbon, oxygen, and hydrogen, so I only need 3 gradients, but this will be my oxygen one. I'm going to use the same gradient that I used for the carbon. I'm just going to change the colors. So for oxygen, I'm going to get rid of any cyan, put a lot of magenta and yellow in there. Get a nice bright red. For the highlight, again, get rid of the cyan, put in some magenta and yellow, get rid of all the black. For my core shadow, remember, I don't want to just increase the amount of magenta and yellow. That's just going to give me a brighter red or a brighter yellow. In fact, if anything, I might decrease that a little bit and then throw a bunch of black in there like so. Here we go. And then for my reflected light, just probably even less of the magenta and yellow and a little bit less black. So I've got a good sphere for the oxygen. And then I can, simply copy that over here, put it right there. I'm going to make it, going to go in here to outline mode just so I can see it better. I can tell that it's a little bigger than it needs to be, so I'm just going to scale it. Oops. A little bit. And also, that oxygen is actually should be in front of the carbon, so I'm going to bring it. I'm going to select it and bring it to front. And I'm going to create a hydrogen also, but notice that the hydrogens are noticeably smaller because they have a smaller van der Waals radius. So I'm going to try to measure a hydrogen. I don't seem to have any hydrogens that are completely visible either. So I'll just have to kind of guess like that. That's pretty good. So that'll be my hydrogen. So again, I'll use the same gradient. In this case, I'm going to let the highlight be pure white because I'm putting a white highlight on something that's going to be light gray. Probably not put any color in here at all, just a little bit of black, just so there's something for the highlight to contrast against. Again, no magenta, no yellow. In the core shadow, maybe do 40%. Yeah, maybe a little darker, maybe 50 for the core shadow, and then for the reflected light, again, no color, just like that. So there's my hydrogen. And for example, if I want to put a hydrogen over here for this, on this oxygen, I can tell the hydrogen's a little small in this case. So I need to scale it up a little. I think my oxygen needs to scale up a little bit too. About like that. Now it's hard to tell if the oxygen or the hydrogen's in front, but it looks like looking at that little curve, I think this is going to work better if the oxygen's in front. So even without seeing what I'm doing, I can go here and say arrange, bring to front. I know that's going to bring the oxygen to the front, even though we can't see that in this outline mode. I mean, just to verify it, if I go back into preview mode, you can see it. But now, same thing I did before, right where the oxygen and hydrogen intersect, I'm going to add an anchor point. Same thing down here, add another anchor point. Delete this anchor point, and then use my white arrow. I got to pull that back very, very close. Just about like that. And not perfect, maybe, but pretty close. And now you see what that looks like on there. So then, do the same thing with all these other hydrogens, just, make copies of them and then trim them as necessary. So I've got, let's see, a couple other examples that I think are a little farther along. So here's another example of that same ibuprofen molecule, just a demo that I've done for students in the past. This is just showing those two different approaches. The top one, I created all three gradients, carbon, oxygen, hydrogen, and then put the atoms together with the gradients already in them, and then did my slice and dicing. And this one down here, I just used circles filled with solid color. And then once I finish it, I would do select same fill and stroke, select the gradient, but then you'd have to position all of those gradients after filling them. So again, upper left quadrant, right through the center dot, bottom right. Same thing with now some of these, the ones that are in the background, the highlights may be completely hidden. That's okay. Or in this case, the reflected light is completely hidden. Some of these that have been sliced and diced, it's a little harder to tell exactly where that highlight, foreshadow, and midtone should fall. The ones that are still intact circles, it's much easier to figure out where to position those different components. Here's another one, done as a demo. Same kind of thing. And you can put, a little black outline on these. These have a very thin 1/4 point black stroke. I'm fine with that. Or you can choose not to put a stroke on them if you'd rather not. And just put the name of the molecule on there and you're all done. I'm going to go ahead and stop the recording. So I don't think there's anything else I need to record. I'll just